Good day! Today we'll go through the proof of the first part of the Fundamental Theorem of Calculus. So ano ulit siya? Sinasabi niya that if a function f is continuous on a closed interval from a to b, then the derivative of the integral from a to x of f of t dt, this is equal to f of x for all x values between a and b. Bakit ito significant? Kasi kinoconnect niya yung concept ng differentiation sa concept ng integration. So let's go through this piece by piece. Start tayo sa expression na to. Let capital f of x be equal to the definite integral from a to x of f of t dt, where x is a value between the closed interval a to b. Let us illustrate that in a Cartesian plane, and let's draw a continuous function f of t and the intervals a to b with an x value in between a and b. Now, the definite integral from a to x will be represented by this shaded region. We already know that this definite integral, yung bounds niya ay hanggang x. Since x can change, then this definite integral is a function. Kaya pwede natin siyang i-declare na function, which we called capital f of x. Now, the left-hand side of the theorem talks about the derivative of the function given by the definite integral from a to x of f of t dt. Nakadedefine lang natin as capital f of x. So let's take a look at that. And by definition, gamitin natin yung limit of the difference quotient. This is equal to the limit as delta x approaches 0 of capital f of x plus delta x minus capital f of x all over delta x. Paglaruan natin yung mga expressions, starting with yung delta x na denominator, gawin natin siyang 1 over delta x na factor. And then, let's take a look at capital f of x plus delta x. Isulat natin siya as the definite integral from a papuntang x plus delta x of f of t dt. Tapos, yung minus capital f of x, i-rewrite natin siya as the definite integral from a to x of f of t dt, yung dinefine natin na function sa taas. Let us visualize itong first term. So, that is the definite integral from a papuntang x plus delta x nung small f of t natin. And that will be represented by that shaded region. So if you remember, yung x natin, it's a bit to the left pa kanina. So x plus delta x, it's a little bit to the right. So mas malaki ng konti yung area nung region na to, dun sa region na nakita natin kanina. And that region actually is the same as yung nandito, yung definite integral from a to x ng f of t dt. So na-represent din natin siya. So what is this difference? Yung nasa loob ng parenthesis. That will be visualized by the region nitong blue, yung naiwan. So, meron tayong region kanina from A papuntang x plus delta x. So, meron tayong region na from A papuntang x. If we're subtracting yung areas ng dalawang region na yun, ito yung matitirang representation niya. But ano ba yung shaded region na yan? Pwede natin yung isulat na definite integral from x papuntang x plus delta x ni f of t dt. So note the bounds, hindi na siya nanggagaling kay a papuntang x. It's from x papuntang x plus delta x. Now we will invoke the mean value theorem. So ano ulit sinasabi ni mean value theorem? There is a value na c somewhere in between that interval na makakagawa tayo ng rectangle na yung area ng rectangle na yun equal dun sa area nung region under the curve. If that is the case, yung definite integral from x papuntang x plus delta x of f of t dt, pwede ko na siyang palitan ngayon ng f of c times delta x by the mean value theorem. Now, look at our expression. Mayroon tayong 1 over delta x, mayroon tayong delta x na minumultiply sa f of c. So, they will cancel each other out. So, now, what we need to do is to evaluate the limit of f of c as delta x approaches 0. Now, you might think, no, na, wala nang delta x dun sa f of c. Baka magsisimplify lang siya to f of c. Pero hindi, kasi si c, dependent pa rin siya kay delta x. Dahil ang definition natin kay c is that it is a real number within the interval x puntang x plus delta x. So, hindi pa natin pwedeng simplify outright. But what we will do is we will invoke the Squeeze Theorem. So, how will this work? Tingnan natin yung diagram. Si c, nandun siya sa gitna ni x tsaka x plus delta x. So, si f of c, nasa gitna siya ni f of x tsaka f of x plus delta x. But what happens when we evaluate the limit? When we let delta x approach 0? So, lalapit yung value ni x plus delta x papunta kay x kasi lumiliit yung delta x eh. And as this happens, c remains in between x and x plus delta x. So by evaluating the limit, we are squeezing yung value ng c between x and x plus delta x. And the squeeze theorem will tell us that that means eventually, yung c natin, that will be equal to x. Kasi may ipit na siya dun eh. So we could replace yung limit as delta x approaches 0 of f of c with f of x. And you might notice that nadating na natin yung gusto nating puntahan. Kasi yung left-hand side natin, it's the derivative of capital F of x, which is the definite integral from a to x of f of t dt. And that brings us to our desired conclusion, na ang derivative ng definite integral from a to x of f of t dt, this is equal to f of x. And this is called the fundamental theorem of the calculus. Well, the first part of the fundamental theorem. So, bakit to importante? Again, it connects the two concepts in calculus of integration and differentiation, na at first glance, parang wala silang kinalaman sa isa't isa. When you talk of integration, you talk about the tangent line to the curve. When you talk about integration, you talk about the area under the curve. Parang walang kinalaman sila. But this theorem, this fundamental theorem, tells us that there is a deep connection between these two operations. And in fact, inverse operations sila ng isa't isa. Salamat sa pakikinig.